Climate change, a global catastrophe made by the hands of us, civilized human beings. We continue to release greenhouse gas into the atmosphere despite knowing the grave, inevitable outcome. The average global temperature has never been so high. Calamity from climate change-related disasters has never been this extreme. And towards the beginning of the end, melting ice caps and rising sea levels will result in a massive relocation of livelihoods and habitat. Bangkok, a major city prone to be affected by climate change. Data from over 2 decades of research show a 5% increase of annual rainfall over the Thai capital city. Tectonic and human-induced land deformation lessens Bangkok's ground level by 3 centimeters annually. And every year, the average sea level rises by 5 millimeters. Many people ask, will Bangkok submerge? If so, when? Let's find out together. Sinking Bangkok, The Countdown, International Online Seminar. Hear it from the experts in this field. Sinking Bangkok, The Countdown International Online Seminar begins in 5, 4, 3, 2, 1. On behalf of the Disaster Communication Development Center, Thai PBS, Delft University of Technology, UNDP, my name is Subhajanklin Suwana. I would like to welcome you all to the International Online Seminar, Sinking Bangkok, The Countdown. As you can see from the presentation, ladies and gentlemen, that Bangkok, Thailand, similar to many mega cities around the planet, located on the coast, is facing many challenges. As you can see from the video, we have more rain coming down, sea level going up, while the ground level is also sinking. So, sinking Bangkok is no longer a question, but it's more of a statement. The questions that follow, however, are when it's going to sink, how bad it's going to sink, and how do we adapt ourselves in order to survive. This online seminar, ladies and gentlemen, will be focusing on the research, satellite subsidence, and sea level data assimilation for mean high water line assessment in the Bangkok area by Assistant Professor Wim J.F. Simons of the University of Delft Technology in the Netherlands. Along with him, here at Thai PBS headquarters in Bangkok, Thailand, is senior oceanographer and expert in water management, Dr. Anon Sarit-Wong. Now, due to the COVID situation in Thailand, a number of people have been limited in order to attend this seminar here at Thai PBS headquarters. However, we do have a number of diplomats, NGOs, as well as government officials from around the world, as well as members of the media who are now joining us via the online seminar. So without further ado, ladies and gentlemen, I would like to take this opportunity to welcome UNDP Thailand resident representative, who is a very close friend of Thai PBS, Mr. Reno Mayer, to deliver the opening speech, please.
For this online seminar. I am very pleased to be part of this event, and I look forward to listening to Professor Simons and Dr. Anand and a lot of the other guests this afternoon. It is a very interesting topic and extremely relevant for UNDP. As many of you all know, we are very much involved and active with the government of Thailand, with civil society on the issue of climate action. And as the UN Secretary General said many times, this is becoming now an existential issue for human on this planet. And there is, of course, urgency in taking action. So I really welcome this event. But I also welcome it because I think it's important that we put evidence and science and data and studies, behind an issue which is being addressed in many different ways, from people that are still not convinced that climate change is an issue, that climate action is necessary, and not only necessary but urgent, all the way to Hollywood producers who offer to the general public kind of an end of the world type of movies that are maybe entertaining but still far from reality. So we need to kind of fill up this middle, and I think events like today's hosted by Thai PBS is a very good venue. I'd like to make three sets of quick remarks as an opening to the conversation. The first, of course, is a set of environmental issues, and we saw in the documentary that opened the seminar, and I'm sure we'll hear more from the colleagues, that it is profoundly an environmental issue, right? So we have several phenomena that are happening at the same time, and the first one being, of course, a lot of pressure from an urbanization phenomenon, right? In Thailand, it's still 50-50, but in many countries, there is a large majority of the population that now lives in cities. And historically, those cities, especially for countries that are bordering a sea or an ocean, historically, those cities are on the coast. Why? Well, it's easy to understand. It's about communications, it's about trade, it's about being open to the world. And for the economic prosperity and the economic development, it made sense to either build those cities directly on the coast or at least inland a little bit, but with a river like we have in Bangkok with the Chao Phraya that links the city and all its activities to the global oceans and the global seas. The urbanization phenomenon brings another dimension to the one that everybody knows of, which is this issue of sea level, which we have seen with global warming, and then the sea levels are rising due to several phenomena, including to the ice melting. But the other issue is that we talk less of is the water extraction, right? It's the amount of water that are required by agriculture, by industry, from underneath, and that we pump, which obviously, as a result, puts pressure on the soils, and then we have this phenomenon of sinking of many different cities, and it's literally, I mean, in the image of people, it's literally the weight of the cities that put pressure, and when you extract what's under, then obviously it's a physical phenomenon of sinking. So you have this, land erosion plus the extraction of water plus the sea level rising. It's a bit of a catastrophic cocktail, if you wish, a recipe for disaster in the making that we are looking at. And I'm sure Professor Simmons and Dr. Anand will give us a lot of interesting insights on those issues from this environmental planetary concerns. But the two other issues that I want to raise quickly are maybe less thought through, and that's the social dimension and then the governance dimension of this problem. I want to put on the table for the discussion this afternoon. The social dimension is that, this whole phenomenon is also marked by an extreme diversity of inequalities. You have, first of all, an inequality of access to information, right? So not everyone is fully aware of what is actually happening. And I think this is a big problem. And this is why I really welcome the media being more and more interested and putting up, events like today's to really inform the general public. This inequality in terms of access to information is, due to inequality to access to education, to exposure to issues, and something that we really need to keep in mind, because we cannot let this phenomenon be in the hands of the scientists. It is really something that everybody in society needs to fully comprehend, so that adaptation measures and action can be taken at every different level, right? There is also an inequality in terms of who gets affected and who will be included in the measures, that will be taken to address the issue. If you think of, for example, in Bangkok, when you look at driving around the city, very quickly we realize that it's usually the poorest of the vulnerable population that find nowhere to establish their homes, but either in some of the riverbeds or above the river, right? And we see a lot of shanty towns on stilts. We see them, getting regularly flooded. We see the quality of the habitat being really poor, and therefore all this informal, settlements are the ones that are obviously going to be very immediately impacted, if not already, by the flooding that you mentioned in the documentary or this issue of overall sinking. So this social dimension to me calls for a generalization of the information, but also very importantly, an approach that will allow people to be more informed so that they can better participate in the discussions that ultimately will affect them. And the informality of their settlement or their income levels or even their marginalization of mainstream society should not be a reason for them not to be involved, and therefore to be even further in a way marginalized or made vulnerable just because they are unfortunately ignorant of the whole situation. Which leads me therefore to my third issue and my last issue, which is a governance aspect. Right? Very often those issues are very long-term, right? Although now we could say they're more medium than long-term given the speed at which all this is being accelerated, right? But when we look at mayors or decision makers of big municipalities that, good thing they are mostly elected, those elections, those votes, happen on a 4 to 5 year basis, right? And then they change, and then the new team comes along, right? And then so it's all about, how do I get to stay in power? What kind of popular issue can I champion so that my chances of being reelected are strong? There is therefore a disincentive built in the system. So for those politicians, those decision makers who are supposed to have the vision, who are supposed to be ambitious in activities like what needs to happen to react to this phenomenon of sinking, because obviously it's not a popular issue. It takes a lot of bold and ambitious and courageous decisions to start moving people around, to take hard decisions on what areas of land needs to be conserved versus exploited, et cetera, et cetera. So there is also a governance phenomenon that I think very often is not taken into consideration and not discussed enough when we address the issue of urbanization and the resilience of big urban centers. A decision like we heard a few months back about Jakarta Indonesia wanting to move the capital out of Jakarta to on another island of the Indonesian archipelago. This is something that is huge and maybe will be unavoidable at some point. But we very quickly see the political backlash, that this generated, and suddenly, the whole topic kind of got, again, pushed under the carpet. So I know my time is coming to an end, but I really wanted to put on the table as we open this discussion, not only environmental concerns, but I think it's important to take a holistic approach to the issue of whether or not Bangkok is sinking and when and what needs to happen to address this phenomenon, so that we look at it, yes, from an environmental and climatic perspective, but also that we don't forget to look at the social dimensions and ultimately the governance dimension of this phenomenon. Again, thanks very much for inviting UNDP to be part of this discussion this afternoon, and I wish us all a very fruitful conversation on a very important topic for ourselves and for the future generations. Thank you so much.
Thank you so much, Mr. Reynold Mayer, representative of UNDP Thailand. Another individual, ladies and gentlemen, who we would like to very much invite to deliver a speech comes from one of the most beautiful places on planet Earth, true paradise, but of course is among one of the countries who will be most affected if sea level water rises. From the Maldives, ladies and gentlemen, please welcome Her Excellency Ms. Huda Ali Sharif, Permanent Representative of the Maldives to UNSCAP, to deliver a speech, please.
Good afternoon, moderator, distinguished panel, ladies and gentlemen. I'm delighted to participate in this seminar. Can you hear?
Yes, we can hear you.
To participate in this seminar on the invitation of Thai PBS, I'd like to thank the UNDP, Greenpeace, and Thai PBS and the other organizers for organizing this timely event on a topic of great importance. Climate change is a phenomenon of serious concern for our world. It is an issue that will define the future we wish to pass on to our children. According to the Intergovernmental Panel on Climate Change, small island developing states like the Maldives are the ones who will be first and hardest hit by global climate change. The sea level rise that is predicted is going to affect us in an existential manner, as Mr. Reynolds just mentioned. As such, Maldives is one of the frontline states in the fight against the climate crisis. We are committed to contributing effectively to the efforts at forging common and united action. Continuous efforts are being undertaken to increase adaptation actions and opportunities and to undertake low emission development. Maldives is also taking actions in accordance with common but differentiated responsibilities and respective capabilities to achieve the ultimate objective of UNFCCC. Let me take this opportunity to quickly outline the Maldives climate change agenda that comprises of 5 overarching policy goals. The first is integrating sustainable financing into climate change adaptation and low emission development measures. The second is strengthen low emission development and ensure energy security for the Maldives. Third is to strengthen adaptation actions and build climate resilient infrastructure and communities to address current and future vulnerabilities. Fourth is to inculcate national, regional, and international climate change advocacy roles in leading international negotiations in favor of the most vulnerable and small island developing states. The fifth policy goal is to foster sustainable development while ensuring security, economic sustainability, and sovereignty from the negative consequences of climate change. Taking note of these policy goals, my government has committed to reach net zero by 2030, an ambitious goal by any standards. The plan is to achieve this through policy interventions and mitigation and adaptation activities jointly with local and international partners. I would also like to mention here that in September 2019, our president announced the Climate Smart Resilient Islands Initiative, which calls for a holistic approach for islands to address climate change in the context of sustainable development. It will be carried out utilizing nature-based solutions, promoting innovation and new technologies, and capacity building and enhancing access to finance. We are also keen believers that building and retaining human resource and institutional capacity is crucial to addressing climate change. On the same front, we strongly advocate for technology and knowledge transfer for mitigation and adaptation activities. This is a pivotal moment in our efforts to address issues on climate change. The COVID-19 pandemic being the loudest wake-up call the world has yet received. This pandemic has spared no country, rich or poor, by exposing the vulnerabilities of our health and social systems and the fragility of our economies. Significantly, it has also highlighted in dramatic ways the need for better disaster preparation. The upcoming COP26 in Glasgow is yet again our chance to avoid future catastrophic global warming. It is a critical opportunity to reach the target of reducing greenhouse gas emissions to 1.5 degrees Celsius above industrial levels. In many regions of the world, excessive rain, flooding, snowstorms, and forest fires are worsening because of climate change. The impact of these extreme weather patterns fall heavily on the nutritional needs, livelihoods, health, and well-being of a large proportion of the world population. Additionally, rising sea levels, acidification of oceans, and habitat alterations are impacting ecosystems due to climate change. Weaving through all these varied elements, COVID-19 has demonstrated that our health and our planet's health are inextricably intertwined. In the Maldives, we are doing all we can. We have also partnered with like-minded countries, as well as private sector and NGOs, who share our goals and concerns. Given our unique vulnerabilities to the effects of climate change, Maldives is highly committed to building back better, greener, and bluer as we emerge from the pandemic. The time to do better has long passed, and the time for more ambitious action is right now. We simply cannot do this alone. We will continue to work with all our partners for our common well-being. Thank you for giving me this opportunity to share our perspective. Thank you very much.
Thank you very much, Ms. Sharif, representative of Maldives to the UNSCAP. We also have another individual who would also like to be delivering a speech. Please welcome Juliano Nebre from AIESEC Climate Action from Brazil, if you would please. Okay, we have.
Can you hear me?
Yes, loud and clear, sir.
Okay, great. Good afternoon. Can you hear me?
Yes, you're loud and clear, sir. Go ahead.
Okay, great. Hi, guys. Good afternoon. I'm Juliano from Brazil. And hi, I'm Juliano from Fortaleza, Brazil. I work with Isaac. It's the global volunteer program for university students all around the world. And here I work close with university students and NGO organizations to work toward reducing climate changes. And how can I say this? But that's really true and really important. We talk about this all the time because the world is changing and it's not in a good way. It's obviously close to my house. I live 20 minutes to the beach, and now I saw a whale, and that's really crazy because I never saw a whale, and on this beach, it's something really, really not good. I already saw a purple shark, and for people trying to understand what I'm saying, our beaches, they are really, really different about the other things. And I'm sorry, guys, I'm a little bit nervous, but what I'm saying here, it's the world is changing, and that's not a good. I'm trying to find a way to help here, and I found some groups. They stay some days at the beach and they clean by themselves, and this is really perfect because people need to understand trash is in the trash and stop to put all these things like bottled waters. And one time I already found a knife, like on the beach, like on the sand. And that's crazy because imagine how dangerous this for kids. Because here in Brazil, I think you guys already know, like we have some restaurants on the beaches, and we have a lot of kids and old persons. And I always stay a whole day just taking trash on the beach, and it's absolutely crazy what we see on the beaches. For now, I want to take a message for everyone who's listening to us. Just stop to take your trash on our beaches because this is killing our animals, and this maybe can kill us one day, like can be in I don't know, 100 years or maybe 1,000 years, but it's killing us. One beach, I never saw a whale. That's crazy.
Right. Thank you so much, Mr. Nobre from Isaac Climate Action as well. So apart from Mr. Nobre and the representatives from UNDP as well as from UNSCAP, we also have a number of government officials, diplomats, as well as NGOs who are now joining us on our Zoom. So if everybody please turn on your cameras and say hi. เชิญทุกคนเปิดกล้องและ say hi กันนิดนึงนะครับโบกมือทักทายครับ All right. We have a number of people there. Okay, good. Now, as I mentioned earlier, that due to the COVID crisis, a number of people is very much limited to attend this in this international online seminar. So, without further ado, please allow me to introduce our two main keynote speakers. All right. So our first speaker is space geodetic data expert on land deformation and senior research associate from the Faculty of Aerospace Engineering, Delft University of Technology, Netherlands. Please welcome Assistant Professor Wim J.F. Simmons. สวัสดีครับ
Thank you.
Assistant Professor Simons has dedicated more than 2 decades of his life in studying tectonic motion as well as water levels in Southeast Asia, as well as the factors which may slow down or speed up inundation within the region. Also accompanying Mr. Simons on stage is senior oceanographer and resource person and commentator on environmental changes and water resource management as well as natural disasters. He is not only one of the experts in this field, ladies and gentlemen. My personal experience being able to work with him in a number of projects really shows that he is one of the people who could explain sophisticated scientific events so that a person who got C in biology like myself could very much understand. Please welcome Dr. Anil Sitwong. สวัสดีครับ อาจารย์ ครับ
สวัสดีครับ
All right, so our topic today, sinking Bangkok. All right, so is it going to be 16 years like some people say, 9 years, or is it pretty much just a hoax? So maybe we'll start with Dr. Anon. If you would please give us the global perspective of what's going on at the moment, please.
Of course. I'll set the scene for our talk today. Can I go for my slide, please?
ขอสไลด์อาจารย์ขึ้นหน่อยครับ
Well, let me introduce about the sea level and particularly sea level rise in Southeast Asia. I think Southeast Asia is one of quite unique in terms of sea level dynamics. Okay, no, this is all right. Okay, I think we have a slide. Okay, right. Okay, you can go for second slide. Oh, I can do this, right? Okay, thanks. Well, when you talk about sea level, of course, there's several terminologies and could confuse people on from time to time. If you talk about the absolute sea level is pretty much scientific and requires some kind of very precise measurements, and it's referred to level sea surface relative to a standardized reference level. So this is a very much technical term. But of course, I would like to point out is that absolute sea level can be affected by several natural factors. Of course, astronomical tides are very important and control sea level. We know that in the sea, in the ocean, sea level go ups and down according to the motion of the moon, the sun, planets. Also, in Southeast Asia, we are under the tropical monsoon system. Monsoon flow in the opposite direction between seasons. And of course, for certain season, for example, during the southwest monsoon or rainy monsoon, we have wind from the south, and of course, it tends to bring the water out of the Gulf of Thailand, so lower the sea level in the Gulf of Thailand in general. And opposite occur in the winter and early summer periods. We also have tropical storms and strong wind breaks that could create occasional rise of sea level or what we call surge. And also we have many big rivers, Chao Phraya, Mae Khong, and others. Freshwater inputs also affect the sea level. Freshwater is lighter, less buoyant than seawater, so it stays on top and make the sea level increase occasionally. So these are the factors that affect, natural factors affect. We also have a mean sea level. Mean sea level, they have to get it through a very long-term observations. Okay, and there's a lot of organization, hydrographic departments, and many others are measuring these, monitoring this sea level and monitor and also observe any changes in the long-term mean sea level. We also, of course, we have a mean and highest high water because sea level is not static, it's not fixed. Certain time of the year, certain time of the day, it become very high, and it could affect human life, society for a certain period of time. And when the sea level can become very low, and then the opposite occur for that. And of course, I won't go much into detail of global sea level because Wim Simons will talk about that also in his presentation. But the concern that we have about the global sea level, because we know that global warming causes melting of many of the land ice, glaciers in particular, and those melted water drain into the ocean and then make the volume of the seawater, global water, increase. Also, higher temperature mean ocean water expand a little bit by temperature effects, and that's also on top of the additional water that added through melting of land ice. But of course, melting and freezing of sea ice, like in Arctic Ocean, for example, doesn't have an effect or has a very little effects on the net sea level rise, as well as evaporation and precipitation, because we normally can assume that these in the long term, in a certain period of time, it will cancel out one another. So what we are concerned at the moment is the melting of land ice and also expansion of ocean water due to temperature change, increase. And this is just to summarize the Gulf Thailand. Of course, Bangkok is at the end of the bay in the north of the Gulf Thailand, and the shape is very important because Gulf Thailand is quite enclosed or semi-enclosed bay, big but enclosed, and it's also Bangkok is in very end the head of the Gulf, and orientation of the Gulf Thailand in general is along the northwest and southeast direction. That's a general alignment of the Gulf, and that's the brown arrow show the monsoon. So that means when the wind coming from the southwest or lower left toward the lower right corner of the map, it tends to suck out the water out of the Gulf, out of the bay. So that means in the rainy season, May, June, for example, average mean sea level at that time will be lower in the Gulf Thailand. But on the opposite, when we have the wind from the north or northeast, it will suck the water from the South China Sea into the Gulf Thailand, and of course, making sea level during that season, like in December, January, higher by several centimeters, several 10 centimeters. That's one of and of course, changing monsoon strength due to climate change could also affect this the natural process as well. And on the other right, I will show you the Bangkok. Of course, it's a very end of the bay, and that means when we have a sea level fluctuate either to tide or other factors, the effect will be propagated, and at the end of the bay, like in Bangkok, it will be highest. Sea level will increase highest, and lowest at the end of the bay is due to effect called resonance. So this is also why city or delta that located in the end of the bay, like Bangkok, will have to be concerned about this location also.
ถ้าเปลี่ยนสไลด์บอกภาษาไทยก็ได้ครับ
ครับโอเค
ครับ
And also, this is what we try to show you also the buoyancy effect due to fresh water input. We have big river like Chao Phraya River, and also when we have a big discharge, sea level along the mouth of the river could be up to 1 meter higher than the average sea level at that time. So temporary effects also very important. And also storm surge. I show you also on the right the effect of Linda storm, 1997. Also, of course, several coasts along the Gulf of Thailand has an unusual rise in sea level due to Linda storm, even though Linda didn't pass directly to those locations. So all these are factors that will affect the absolute sea level. Next slide, please. Okay, and then I come to the end of my introduction. It's a relative sea level. This is more important for human, for the society, because this is a sea level that is relative to the land. We are people tend to be living on the land. We settle, we build cities, and so on. So what we concerned is about how sea level will rise or lower relative to the land level. And it's one of the concern about Bangkok, and Wim Simon will talk in detail, is about the movement of land up, sinking. Mostly we are talking about sinking of the area around here due to several factors. And that will be the subject, of course. I'll give Wim to deliberate and give details about it.
Right. Thank you very much, Dr. Anon. So now, Professor Simmons, if you would please now share with us your perspective. And of course, along the way, Dr. Anon, if there's any place that you could help to explain, especially in the Thai context, as well as not only in scientific, but also social and political, please do so. All right, so Mr. Simons, please.
Thank you. First of all, of course, I want to thank Thai PBS for this opportunity today. And it's been a long time since I've been able to come to Southeast Asia, but I'm happy, although with all the rules, but I made it. I'm happy to be here again, do some work, and have this opportunity today. So I'm going to have my presentation today on the topic. And my aim is also for a wide audience to you to explain what is going on. So although I'm doing the science, I'm not going to throw equations at you, but I'm trying to show you what we have done. So if I can have my
Yes. ขอสไลด์หน้าแรกของอาจารย์วิมเลยครับ All right.
Okay, so the title is already mentioned. Just quickly, I think when you want to know where we are, for the people outside Thailand, of course, we are where the yellow dot is, the yellow star is blinking. That's where we are located. Of course, we have, of course, Southeast Asia. It's been very familiar for me for a long time, but yeah, of course, you're wondering where we are situated. You can see in the background. So the topic today is already mentioned. Is mostly about what do we know from satellites, mostly satellites, not only satellites, about the what is going on with the sea level on the one side, right, for the sea, and on the other side, of course, for the land. And what we have done, that I think we have spent about 2 decades of research, not only on Bangkok, but in general also on Southeast Asia, on the tectonics, as already mentioned. I did quite some work also in Indonesia. So I will go show you quickly the contents. So first, I think it's important that we define what is sinking of Bangkok, you know. And already the answer is already given by Dr. Anand also. It's about relative sea level rise. Relative means that relative to where you are, what the sea is doing. So if you are just staying the same position, then it's like absolute what global effect is. But if you're going up, you might be lucky. Although I will show in this presentation, there are areas going up, even in Thailand, for a certain period. But also you're going down, then of course the sea is going to go much quicker. So I'm going to go illustrate it to a slide. Then what are the first signs we have noticed already in the past that something is happening to the greater Bangkok regions? Then I will go to the space techniques we use, but not in a detail, just in a way that you can understand. I must mention we also have data from the ground, like tide gauges. So these are equipment which measure the sea level, local areas all around the world. Then, of course, I'm going to show you some results on the sea level, which is not, of course, only for Thailand,
Right.
but also for all Southeast Asia.
Great.
And then Bangkok, some results. I briefly want to mention the one earthquake, the big earthquake we all remember, because
Tsunami,
it has something to do also with the vertical motion. Not that extreme for the Bangkok region, but it's something we should quickly touch on to. Then I want to show you the study case for Phuket Island, where we have combined already. It's a bit different than Bangkok because Phuket is mostly a rocky island, but still it's interesting to briefly show. Then, of course, we're going to go into the Bangkok regions, and we're going to talk about land erosion, land subsidence, and then the vertical motion from GNSS or GPS was the first technique, which is mostly my own expertise I've been using, and then also a little bit about the aquifers and groundwater wells. And then I have some scenario at the end, because many people ask about the prediction. Is it 9 years, 16 years?
Right.
And I think we don't know all the answers, but I can give you some idea.
Or maybe next year.
No.
Too soon.
Maybe, yeah.
Let's hope not.
You never know, but normally it will take some time. First of all, I want to say on the next slide that I will talk as we, because although I've been behind a lot of the research and getting funding, it's multidisciplinary research, which meaning many people involved with their own expertise have to work together from a scientist point of view. I think later on, I think Dr. Anon can also explain from government or policy, you need a similar activity.
Right.
So one person alone cannot answer the question in science, but of course not on the policy decision making. So there we have colleagues, I don't want to go all better, but we have both people from Europe, but we also have colleagues we have been working for a long time.
Right.
And actually many more than I can put on the slide, but just to show you. So there's some universities from Europe involved, but also from Thailand,
Right.
and also government agencies. So I'll try. Yeah. So actually this is a slide. I took myself the picture when I arrived, 2.5 weeks ago. I arrived in Bangkok, and looking at the nice scenery, of course you see there the coastal line, you see the Chao Phraya River, Mount, and then of course where the cloud is, Bangkok, and below Samut Prakan, which is actually, when we talk about actually, it's already considered part of the greater Bangkok, so that's also something, what we define as Bangkok, is it just the old Bangkok part of the whole area? That's also an important thing to see. So something I noticed, well, you cannot notice from the air, but if I would have flown 30 years or 40 years into Bangkok, other airport, but I will still see the same scenery, then I would have seen that actually on the west bank there is a temple which was at the, I think in the early 70s, it was at the coastline. Actually, it was behind the coastline, and nowadays it's already 1 kilometer into the sea.
Right.
So this is already a sign something was happening. You know, of course, if you fly every day and the change is slow, you will not notice. But if you would see the image from many years ago and now, then you suddenly see.
Right.
So it's not something which is just starting quickly, but it's a process which takes quite some time. So this I don't want to talk about. I think yesterday there was also shown Time BBS about the global climate predictions. This is not my work, but we have an expert in our team who works with the people that, of course, there are a couple of scenarios of what would happen based on global warming related to emissions. And then they have a less case scenario. It's the RPC, the RCP, the first one, 2.6, or another one in the worst case.
Right.
And then you would see actually what it would do to the water level.
I see.
This is the absolute sea level.
Right. So we've seen the change going on for the past 4, 5, 6 decades already. So if I were to ask you, what is the main reason for the possible submergence of Bangkok? What would you say?
Yeah, now that's a good question. So I'll try to go actually. When we saw this, of course, I've been to that temple. It was an excursion. It triggered for me, you know. So what's going on here? So because I mentioned the coastline here, actually, it moved 1 kilometer inwards in the past 40 years.
Right.
Okay, so that's quite a lot. So because the temple before was at the beach, then actually because they wanted to protect it, it's still there. They built a wall of it. That already gives some hint, you know. If you want to save your temple, what the monks did long time ago, you build a wall around it. So if you don't put the wall, the sea will just come into the temple and it will damage it. So of course, because of that, I think we start to think, and then we know, of course, we had the global sea level rise issue, but that's also playing, but that could never explain this. So there must be something else. The only other logical explanation, regardless the cause behind it, because for science we just observe what's going on. We don't have to point out what's the reason. Is that we have here a case of severe or higher relative sea level rise, which means the land must be going down in that area. at least in that area, and maybe in more areas. Of course, we have to measure, because one thing only they could say the temple is built on a small foundation, and it's a swamp, and the temple sinking itself, so nothing is going around. So we need the more science results for that.
Right.
So I'm getting so.
Yes.
Yeah. Okay. Actually, I show you here. These are pictures I have up on TV when we visited there. You see on the left, you see the old image in the 70s, I think, where the temple is still at the coastline. So we really have the proof it was there. And then you see in the next picture that the temple is going more and more into the sea.
Right.
Actually, if you look around, you get another hint. You see a lot of agricultural fishing farms in the area.
Yes.
So that's just to illustrate.
Right.
So there are these possible causes. There are different ones. You can mention. You can say there's erosion of the central plain of Thailand. It's a big plain extending a further distance. There is also changing in sediment deposit on the river delta. There are many things which are possible, and there are many ways to measure it. But one which comes out on top really is the sea level rise. And then the absolute, like we explained, is for the whole global. If it's just what the sea is doing, relative, what you are living or where your city is with respect to the sea.
I see.
So actually, that one is one we want to have a look at. That doesn't mean all the other factors are also not have an impact. But what might be the biggest one, we can find out. We try to find out.
And what's going on here, you with your colleague, Captain Samat, is this like the scientific data or techniques that you're using to measure as well? Can you explain what's going on here?
Yes. Okay. This is actually a station. We call it it was a GPS station.
Yeah.
That's one of the techniques, and this one is actually used to measure the position of that building or that location in Bangkok.
Right.
So with the satellites, we can estimate on millimeter level the position every day, and on many years we can see what's going on, both horizontally or also vertical.
Vertically as well.
Yeah, and the vertical one is actually the one which is important for us for the land subsidence. Because we also measure at the sea, but we also have to measure what the land is doing. So this station we established, and yesterday we renewed the equipment for it. Hopefully can run again for 15 more years or longer, because we need many years of data to come up with a straight, solid or a clear signal about what is going. And it can also change. It doesn't stay the same. It can go up or can go down more. So the city can sink more, or it can slow down. There's many factors involved.
I see. Ajahn Anand, if you have anything you would like to add or comment, please feel free to do so.
Yeah.
Okay. So you're a really hands-on kind of person, Professor.
It's one of my hobbies also to be technical, and we try to make the stations so they don't break down quickly. We even have some stations in Indonesia on a mountain which we could not go for 3 years. But the station is still working. We use a solar panel, but I like to design and make it all as good as I can. But it helps, to be, and it's a nice, different from the computer and the analysis work and the practical work. So.
Okay. All right, now, so moving on, sir.
Yep. So the techniques I already mentioned to you. There's a couple of techniques we can use. And there's basically 3 of them involve satellites. The one you already mentioned is the GPS, or nowadays we call it GNSS, Global Navigation Satellite System. That is because GPS was the first system. Now we have more. We have Europe, Galileo. We have China, Baidu, Russian GLONASS. So we have to, but most of our work is coming from GPS because that data we already could collect from a long time.
Right.
And then another one we refer to SALT. We call it satellite altimetry. That's a satellite looking to the sea. And then we have the other one we call SAR or INSAR. That's also a satellite, but looking to the land. And then the last one actually is the tide gauge, which is the instrument sitting along the coastal regions or in the river, and it's monitoring the sea level on every day. So you just get like a floating device, and it will move up and down. And then my own GNSS you can use with all these techniques actually to get the vertical absolute information.
Right.
Because some of them are relative.
I see.
It means only in a certain area. So.
Okay. Dr. Arnon, you've been with the government, being advisors to a number of governments. Are these also the methods that the people here in Thailand are also using as well?
Well, yes and no. Well, we have people or agencies collecting these data, but data are scattered. It's very rare for anyone to bring together all these data, which is very valuable because it's a long term.
Right.
So this is one of the efforts. They are one of the to bring all those data and analyze together.
Indeed. Thank you, sir. Professor Wim.
Okay, so I move on to the first one, okay, which is my own expertise, what I've been most, just to be brief, there we have the station on the ground and getting the data from the satellite. Just like the GPS on your phones,
Yes.
only we can do it more accurately with the special equipment. We can get down to millimeter, while your phone can get your position 3-5 meters.
Down to the millimeter.
We can get to the, we can even get in the horizontal, we can get sub-millimeter. But it's not real time. It
Right.
means we collect the data for 24 hours,
I see.
multiple days, and then later on we process the data
Okay.
with very detailed information from the satellites.
Yes.
And now we can do this.
Okay.
If we do this for many years, we can see any changes in this position, and this is actually the information we can use for the vertical direction with regard to the land subsidence.
Okay.
So then we have the other technique, and here I think there's a small animation or video made by ESA. This is actually the satellite altimetry satellite measuring, and how it is basically working, just to keep it simple, it's a radar. A radar sends a signal, like if you want to detect the aircraft approaching the airport.
Yes.
It bounces back on the sea in this case, comes back to the satellite. The satellite measures how long it took for the signal to start from the satellite and come back to the satellite. It travels around with the speed of light, so we have these many pulses. And what we have to do, this is also something my university is also doing, we have to, of course, know where the satellite is very precisely, within a couple centimeters.
Right.
And then we know, if we measure to the sea and we do that, you can get the result, because you will see the change in the sea going. Of course, there are, like Dr. Anand explained, there are also seasonal variations. But
Right.
if you look at a very long trend, then you can see what the sea is going up or down globally, and or in regions, regional areas, you know.
Right. So
And you can also look at the variability, so the seasonal effect as well, because
Yes.
there are signals. There are signals which have different periods, so 1 year or longer. And of course, what we are talking about here is, of course, the longer term, what is going. And then you can see actually from on the bottom right, you see the tide gauge. This is the tide gauge. The one is on the coast. This already operates for more than 100 years. It's an old system before with a roll and a pen going up and down.
Yes.
Also, Thailand had it. They very nicely collect the data for many years, and it gives you. And then since the early 90s, we have the satellites. Both the satellites actually, on a global scale, and the tide gauges, they confirm both the same signal.
Right.
The sea level rise is going, and it's actually going a bit steeper, which means it's increasing actually.
I see.
So that's the one technique. Then very quickly we have another video where we have a star satellite. It's actually also, again, a radar, but the way it measures is a little bit different, but the same principle is you shoot your radar signal goes, it reflects from buildings or on the ground, goes back to the satellite. Again, we measure how long the time is. We know the speed of light, so we know the distance it traveled, the distance by half. And then they do that for a big region. The radar can cover an area 50 by 60 kilometers, and you have to repeat. So you do again 1 month later, or you do again 1 year later,
Right.
and then you can start to compare the images, and there you will see anything going on. And we call it relative because it cannot see if the whole area is going up and down, but it can see changes within the same area. So that's why the SAR is important.
And this is working 24/7 as we speak. It's still measuring.
No.
The satellites, they're still flying when one satellite is out and a new one comes, you know. And actually, Europe now this is a Sentinel satellite, and the data is also public.
Okay.
Because that was also an issue in the past. Sometimes you had to pay for the data. So you can get the data, and many countries, they always assure that there's at least one satellite flying, collecting the data, so we can continue to build. We need the satellites. If we stop using the satellite, we cannot, of course, do this. So you see two examples, one for the earthquake. The colors just show you the difference in land motion, you know. One is on the earthquake. The right is actually an area in Bangkok. Red means a lot of subsidence, and the greener or to bluish color means less. So you see there's an area there which showed a strong signal. That's just, I will get to that more in detail later.
Right.
The tide gauges, sorry.
Yes.
Yeah, the tide gauges is very simple. They're, well, very simple. They're located on the coast, like I tell you, and they measure the sea level for a long time. Of course, you have to be careful. You replace the equipment that you always keep it at the same hide. So you have a lot of administration to make the data from like 100 years useful.
Right. Okay. Professor Wim, before we go on any further, to the audience who's watching our live online seminar at the moment, we do have a session where you can leave your questions or any comments along the way. And if any questions that the team sees that we should be asking Ajahn Wim along with his presentation, as well as Dr. Anon, we will do so. So please don't hesitate to leave any questions through the comment section as well. All right. So the next question would be pretty much, what have you and your colleague been doing in Thailand or in Southeast Asia for the past 2 decades, and what have you found out?
Yeah, we go to the next one. We have been actually involved in quite some projects since actually I think 1994 we started. I think originally it was tectonic driven. We collect all that data. And of course, like I mentioned, the vertical motion in that can be important not only for tectonic but also for land subsidence. So we have quite a long history. And then we started also already working the GO2 TEC-D. We tried to make that sound good in Thai too, TEC-D, so good technology. We had 2 projects together, and we already started to look also at the sea level rise and the impact of earthquakes. So we collected a lot of data ourselves, but or also from the satellite missions, we were able to get the data, Some data is because we work together, some data is public. So we collected quite some data, and that shows, allow us to get a little bit insight, better insight in what's going on. So I'll go on to the next one. If the point, okay, sorry, I have to go one back. So what we do ourselves, we try to combine all these different measurements. I show you about from the radar satellites, from the ground we have. This is just an illustration where we show this could be the Bangkok city, you see, and then we have the satellites measuring the sea, the satellite measuring also the land deformation, and the GPS stations measuring themselves, what they go down, and we want to study this whole interaction going on. And actually one thing we will add in is also the groundwater extraction. In the previous project, the result I should show you very soon, we did not take into account that factor. We knew about it, but in the new study, that's a new project now, one of my colleagues is doing for the next years, we're going to keep all the data we already have, we put in, but we're also adding new data about groundwater pumping and all this information to even get a better idea and to be able to make more accurate predictions. And then in this case for Bangkok, of course.
I see. So this is the results for the absolute sea level in Southeast Asia.
Yeah, this is actually the first one I show you here is the first slide is the yearly cyclic behavior Dr. Aron talked about, and there you can see indeed that in the Gulf of Thailand there's a big difference, between in the seasons. So the water can be, the mean sea level can be higher for part of the year, lower as explained. But then the one, of course, the one which is the more interesting one is for this seminar. This is the estimate. I think this is based on data till 2018, and this is showing the absolute sea level rise in Southeast Asia. And then, of course, the red dot, which you see up there, that's where Bangkok is. And there you see we are around the 4 to 5 millimeter per year. It is a bit higher than you might expect from the global. But actually, this is because we can have variations, So the global models, they are good, but they don't give you all the detail on a specific region. That's why we sometimes need further analysis. But this is one we can really see already for now. We have about 5 millimeter per year absolute sea level rise in the Gulf of Thailand. So every year it's 5 millimeters. It's not much, but if it's for 100 years or 200 years,
which explains how the temple got into the middle of the water in the first place.
Yeah, for one point, but still the temple went down by 1 meter. And 5 millimeter per year, if we calculate back, it's not enough. It will only explain like 25 centimeter. So we need to find the other 75 centimeters. Of course. But that one will come from the other one. This is actually a past result from my Thai colleague, in cooperation with all of us, but he did a lot of work on it. Or this is already an older result. There's a new one coming up. This is the SAR. So red means subsidence, going down, and then blue, very dark blue would be 0, so that area would not be affected. So you see there are quite some pockets in the Bangkok area where you see strong subsidence. Actually, the area with the temple is in the bottom of the graph. The problem only there is because there are so many fishing farms, the radar cannot get always a good signal back. So unfortunately, we don't have the good data. You need to have a building or or a concrete surface to reflect. But we have still small points there, and they also show strong subsidence. What they showed us in the past was up to 30 millimeter per year. So that's 3 centimeters per year of land subsidence for the Bangkok region.
I see.
So up to. It doesn't mean the whole city is going down by 3 centimeters, but some areas, especially the coastal areas, they show quite some. And if we add that, then we get closer to what the temple has been done since the 60s, you know.
I see.
The combined effect.
Now, Dr. Anon, if I may, please, this data is pretty much open to everybody, including government agencies. Knowing this, has there been any dramatic changes in policy, or at least in land relocation, or in any, what do you call urban planning to cope with this?
No, unfortunately.
Ouch.
But because at the moment we do have some policy, particularly policy toward prevent from Bangkok from flooding. And many people believe that at least so far, that policy hit in to some degree would still cope with long-term climate change.
Right.
But that's now a lot of people challenging.
I see.
This and that's I'll mention about this in my conclusion.
Okay, thank you, sir.
Today.
All right, Professor Wim.
Yeah. Okay, so on the previous slide I showed you the subsidence, but some people might say, yeah, it's satellite data. How do we actually know it is going on in Bangkok? You know. So this is actually my colleague. He went on survey in Bangkok to look, and what he found is a couple of areas where you see that the building, of course, looks like it is, but the soil around it is going down. That is because the buildings are on pillars, foundations, they go deep. They also can subside, but generally most of the subsidence is happening in the upper layer, like 20 meters deep. So what is happening is that the land around the buildings is going down, and you see clearly evidence in many places in Bangkok after they construct. You see after a couple of years the land is going down. So this is also something you have to be aware of. The buildings themselves, they also subside. But they might subside lower because they are on deeper foundations in many major cities. Because Bangkok is up to 2,000 meter sediment layer, so there's a lot of sand. You know, if you put your building on a rock, then it's mostly only going to move, if anything, with tectonic.
Right. Now, growing up, subsidence is always growing up as a Thai, is always blamed on pumping up underground water. Is that the only factor?
It doesn't have to be, it's surely not the only factor, you know. Of course, like already was mentioned in the introduction, if you build a big city and big buildings, you add weight, okay?
Right.
This also will cause sand compaction. But in general, that stops after a while if the sand is compressed, you know. I think there's a study, it says for a big city, it's up to 8 centimeters, you know, that it normally matters. So that stops. So the only thing which is still left and to go on is that if you pump water away, or you have pumped water away in the past, because it's a process, the sand is slowly to react. It's not going to instantly. Then you mostly see this signal, which can continue for many years. So part of the problem, as already was said, is of course the urbanization. You go to an area. Another problem is of course if mangrove forests, for example, disappear on the coastal region because farming needs them. We have the same in Europe. We cut the trees because we need to do. That might help, but that all cannot explain the big signals we see. And then the only one which still remains as a big contributor, and the biggest one, I think, is the land subsidence due to groundwater pumping, which is a normal thing to do. Every economy needs water, of course, but it needs to be managed to do that. And the water of the river now, we have the same problem in Europe before, is polluted, so the farmers cannot always use it. So then, you need to pump up water, you know, in some way. And there are many aquifers in the Bangkok area. There's less deep and more deep, you know, so depending on what. So that one is a key factor still. We're going to study this more in detail, because pumping has been limited by the government. We've shown that. I'll show you one of the last slides. But still, that doesn't mean it's everywhere. And also there is sometimes a delay effect, you know, a response of the sand, of the sedimentation layer.
Of course. And we talked earlier before the seminar, you mentioned that there's not only human-induced factors, but also tectonic as well.
Yes, and that's why I want to briefly touch this. For Bangkok region itself, it's not a very big problem, but we actually had this big earthquake far away, but actually the tectonic plate, where also Bangkok is on, is in a state of deformation. Before the earthquake, actually it's been pushed or compressed by the other plate, and it's starting to bulge like you would do with a piece of paper. So it's going up, and then after the earthquake, it's going down. So you get a cycle due to the tectonic, which means that in one part, the land might go up, just depending where you are. For part of this seismic cycle, they last a couple hundred years, and then for another part, they might go down. Now, actually, for Phuket, that was actually, we measured with from the GPS that the island was moving up a couple millimeters per year before the earthquake, and after the earthquake, the island started to move down. So we get actually uplift from subsidence, we call tectonic, and after we go down. But actually, there in Phuket, it was not such a bad thing, as I will show you in our study case.
Okay, so far we have one question from the audience who's participating from the Zoom conference. However, we're going to be gathering all the questions first. คำถามนะครับขออนุญาตพูดภาษาไทยสำหรับทุกท่านที่กำลังดูอยู่ตอนนี้ถ้ามีคำถามที่อาจจะไม่สามารถที่จะเขียนภาษาอังกฤษได้เขียนภาษาไทยมาได้นะครับทางเราจะยินดีแปลนะครับเพื่อที่จะให้อาจารย์วิมตอบหรือว่าถ้าเป็นภาษาไทยก็ให้อาจารย์อานนท์ตอบได้นะครับขออนุญาต Okay, back to English mode.
So just briefly for Bangkok, due to this tectonic, we estimated a couple of years ago that the effect is small, but actually after the earthquake, Bangkok was going down, also Phuket was going down, and we estimate the total effect could be at the maximum would be smaller than 10 centimeters, So that's not a big. So, but actually at some point it will move up again. It's just if you would build the dike, you would probably add the 10 centimeter extra as a safety margin to make sure you put it high enough, Right. So it's not a big thing for Bangkok, but it's a detail. And in this work, we sometimes have to look at the many details, because many details together, they can make a bigger effect also.
Right.
Okay, so we move on to the case of Phuket, which is a study we already concluded. We work with similar data there. We have the GPS station, we have the tide gauge, very nice location. We have an old point. It's actually already established in all projects and measured by the government, by the Royal Thai Survey Department for many years. So we have a lot of data on the motion of Phuket Island, and also the satellites pass over Thailand, Phuket as well, and they also gather data. Land subsidence here we have not looked at because it's a rocky island, so there's a thin sediment layer.
Right.
But we have looked at sea level rise data from the satellite to have an idea what is going on there. And then you can see on the western side, you can see there's a clear change. I just want to talk about the vertical motion, which is in the bottom panel. You see that there's a phase where the island was moving up to around the point of the earthquake in the end of 2004. And then there's a phase where the island is starting to sink down, really sinking down, if you want to. But you see already that the sinking down motion is actually becoming less and less, because it's due to the tectonic. So normally it's not going to continue at the same rate. It means a lot in the beginning, and then it slows down.
Right.
For Phuket, actually, it was good, because the coral reef, I just want to briefly mention, is in danger in many places. But coral reef is happy if it has more seawater above it. So actually, the coral reef responded around Phuket positively, at least in the first year, because it has to endure many other factors as pollution of the sea. But there we could clearly see the impact also on the relative sea level rise.
Also, and this is the picture of เมื่อกี้เป็นรูปอยู่ไม่ทัน that was in Phuket,
yes,
right?
Yes, that's because I also that's the one point. So I also, not always, but sometimes I also go there to maintain the stations and also carry out extra measurements when I'm there. So I sometimes refer to as a work holiday, but at the end it's more work, but a couple brief moments. So that's one of our stations in Phuket.
Right.
We set up permanent stations, GPS, so it's close to the sea, and we have done that to measure. There's more stations, but again, the more data, the better you can compare. This is a station near Phuket. We use a solar panel so it can work independently.
Right.
So we don't check. Normally it works fine. It can work for 1-2 years. Nobody going there, So.
Right. But you're going there tomorrow.
Yes, I'm going there because one of the equipment broke down, and we have to visit. So it's urgent travel, and I think we should be fine to go there, because now of course we have more measures, but there are exceptions, and we have to go there for the work just a couple of days, and then we return. So.
Okay. The topic of our seminar is, of course, sinking Bangkok. But apart from Bangkok and Phuket that you have mentioned, is there any other parts of Thailand that we may need to know any information regarding to the sinking?
Yes, as I mentioned, we just talked about Phuket in Thailand, but it would be in Bangkok. It would, of course, be strange that just those two are affected, So I want to okay, this one we already discussed about before. This is. I don't want to go into detail, but it's just again showing this effect, in Bangkok we have seen in the past, and the coastline is retreating. But to move on to answer the question is that we actually know from our studies that that the relative sea level rise is the biggest component, and we've seen in the past that land subsidence up to 1 meter in the Bangkok area has been there, and so it's not something just started very short period ago, but it's already for long ago. The other things, yeah, like I mentioned, groundwater pumping. You know, if you think you ask me, is it just Bangkok? And so any region where you would extract a lot of water. And all the regions which are coastal regions are bounding the same sea,
right.
They might be affected. So the two examples now, Bangkok and Thailand, doesn't have to be, or of course not the only areas. We just focus on those because Bangkok is important as being major city, but it's of course true that there's more areas. Basically, all the coastal regions might be affected, and especially the regions which have a low slope, which means the land is only going up slowly from the coastal areas. There are other areas where you have rocky island and you quickly go up. Then, of course, the effect is much less of the sea level because it cannot go quickly up to the rock.
Of course.
But if the surface is flat like a plate, it can quickly erode. So that depends, you know. It has to do with the elevation and also the layer those areas are built on.
Right. Indeed. You mentioned that mangrove deforestation has promoted faster land erosion. Ajahn Anon, you and I, we've been to a mangrove preservation area. I don't recall which province, but they seem to be taking quite good care of the mangroves. But in the big picture, along the coast of Thailand, how well is the mangrove doing?
Well, these very interesting questions because now we see many mangrove has been reforested or afforested, growing like trees like Rhizophora, Kungkang, and others. But whether this mangrove reforestation really help the area to collect sediments or not is still questions. Because sometimes we can see that growing certain kind of mangrove trees is not effectively collect the sediment. So there are people looking not just only growing the trees, but also how to restore the whole ecosystem, including plants and animals and others in the area.
Right.
But I think I just recall your questions that other area, well, of course, when you talk about the sea level rise, most people are talking about the head of the Gulf of Thailand, Bangkok, a little bit to Phuket. But many other places are also at very high risk, like Chantaburi, Bandon Bay in Surat Thani, and also Songkhla, and other this area, Pattani in particular. So we have very little knowledge, but I think it's quite a good opportunity for Thai PBS, for example, to focus into this area and see how people in the area, whether they concerned about this or not.
Right. Okay. Professor Wim, please.
And I like the mangrove also, but one thing I also want to add, of course, if the coastal area is still going down and you put the new mangrove, if the mangrove are submerged too long, they also die, you know, because they have to stay for a certain period of time.
Yeah.
So it's a quite interesting topic also to go. Actually, to completely add on to the discussion, this is the latest result, I think, of data. It's up to last year from one of the new satellites, the European satellite. This data is, and many governments do that now. It's freely available. Of course, you need the tools to process it, but also Thai scientists can and do actually also, because we cooperate with some of them on this. And this is an update of, this is a first result only, but it's not perfect yet. It's low resolution, which means it's areas, the colors are for areas 1 by 1 kilometer, while they can go to a high resolution. But what this shows you that even now, on data based in the last 5 years, the coastal regions, and then with especially Samut Prakan, Bangkok, of course, also have its own small coastal region, but also Samut Sakon. You see there the yellow to red colors? This is really high subsidence going on. And the rates, you see, that's from the color scale. Although it might even be a little bit more because we have to fine-tune, because the blue would mean that some area are moving up, but that's just a calibration because these results are I think only 1-2 weeks ago, we got this results from our colleagues in the UK who work with us. They show that it's not only Bangkok, it's only the eastern western bank around Bangkok, but also now it seems in Samut Sakhon you have another issue. Now you can even go down. I think on the corner, we almost passing close to Wain, I think the area. There also, I think you also have a pocket. It's more hard to see. But everywhere where you see this yellow to red is subsidence. Yeah. So the rates in the past year in these areas, we will still detail it also for the Bangkok. Bangkok looks a little bit more stable in this area, the central area. But it can still mean that it's still going down, but at a few millimeters per year. I will actually show that on the last slide based on the GPS. Right. But we still see 1 to 3 centimeter per year land subsidence for the greater Bangkok region in the past 5 years. So the land subsidence is still going on. It's not stopped yet. But it might change from area to area. And of course, the big correlation there is groundwater extraction or building new areas, urbanization or industrial estate. That has to be the main contributor. Because, for example, some coastal areas, you see a lot of there, especially the Samut Prakan area, there are no buildings there, but still the coastal area is going down. Yeah. So it cannot just be only from the weight of the buildings, which is a factor as well if you build, but it cannot be the major role. So you cannot say it's because of the weight the Bangkok city puts, the whole coastal is going down. No, right. It's a factor, the weight of the buildings, sure, but it's not the biggest one. And especially if you see coastal regions where there is a lot of fish farms or agriculture and no buildings, you cannot say it's because of the weight of the buildings. So it's a sea level rise we not see here, but of course the sea level rise only make it worse because the land is going down in all this area. It's basically most of the head of the Gulf of Thailand, you know. Right. And we could expand this research because you can see it on the left. But of course the western side, Chonburi Rayong, there the coast area is more rocky, you know, and less sediment. And immediately you see there that there is not strong signals of. The small beach might be affected, but not the whole city behind, because the rock area is going up quickly. So this is one of the latest results. So no, it's not just Thailand. It's other countries, Jakarta, Vietnam, many cities facing the same as already.
Now that you mentioned this area, I'd like to ask both of you, Dan Wim and Dr. Anon. This is a question from คุณสมชายแจ่มจรัสนะครับคุณสมชายมากนะคุณสมชายถามมาว่าถ้าสร้างเขื่อนกั้นปากแม่น้ำเจ้าพระยาจะทำให้กระแสน้ำไหลพาตกรไปตามชายฝั่งหรือไม่ So let me just translate that real quick. And if we were to build a dike or a dam along the Chao Phraya River basin, would that help the sediments kind of like would that help in that sense? อาจารย์นนท์ครับ
เอา answer in Thai นะคุณสมชายจะได้เห็นชัดคือสมมติเรากั้นเนี่ยตอนนี้แม่น้ำเนี่ยหน้าที่มันคือเอาตะกอนลงทะเลนะครับสมมุติเราไปกั้นเขื่อนที่ปากแม่น้ำนะนั่นก็หมายความว่าตะกอนที่มันควรจะไหลลงทะเลมันยิ่งไม่ลงนะครับเพราะฉะนั้นมันตะกอนที่มันจะเข้าไปเสริมหรือทดแทนไอ้ตะกอนที่ถูกพัดพาออกไปตามธรรมชาติมันก็น่าจะน้อยลงนะครับเพราะฉะนั้นมันจะน่าจะยิ่งทำให้การกัดเซาะตะกอนออกไปเนี่ยมันรุนแรงมากขึ้นครับ
Right. So according to Anon, that would be pretty much worsening the situation because of the sediments not being able to go down to the sea. John Wim, you want to add anything to this?
Yeah, I mean, if you talk about dikes, of course you can protect the coastline, you know, with dikes as we did in the Netherlands. Of course, but you have a lot of water which has to also exit and go. So it's so I think one of the solutions, of course, is that you have to build some dikes along the coastline to protect the coastline further. But to, for example, close a whole part of the river to protect it from the flooding, it will also be ecologically very complicated.
Right, as you mentioned, a big.
I mean, it is technically feasible. It's just the question: is it the best solution? I mean, my personal opinion, I would not advise that. But of course, that's at the end on. But something has to be done.
Right.
Of course,
เพื่อตอบคำถามอาจารย์สมชายนะฮะของคุณสมชายนะครับก็อย่างที่อาจารย์อานนท์ได้พูดเป็นภาษาไทยอาจารย์วิมก็เสริมว่าจริงๆสร้างเขื่อนมันก็กั้นได้กั้นน้ำออกได้แต่ว่าคำถามที่เกิดขึ้นคือแล้วหายนะทางนิเวศเนี่ยมันจะเกิดอะไรขึ้นนะครับซึ่งอันนี้ก็เป็นสิ่งที่บางทีเราก็ต้องมาพิจารณากันให้ดีเหมือนกัน Alright. So moving on, sir.
So actually, we overlay the previous result. Just to add, you know, what we have, and then we actually see that it's the first result, but it's, like I said, this new urbanization area there we saw in the previous, we don't see this big subsidence anymore there, but we still see some lower rates. But as I said, it's not constant on the same location, you know, and it's this correlation with activity or urban development going on in certain areas. And of course, in Thailand, there's much more change, like in Europe, because there's still more land available to do things. So we compare the old results, we compare with the new ones, and we're going to refine, and then we can also zoom in specific areas.
Right.
You know? So that's why we, of course, work. It's not my own expertise, but they still need my own data, as I will show. We get, this is basically a Google Earth image, and then you see a couple locations where we have the GNSS station, the same one you asked me the question about earlier on, and they monitor the motion of those, all those locations, you know, in millimeter per year precision. So those are, they show you any land subsidence, but as I told you, they are mostly on buildings which have a pillar depth of 20 meters. So what they measure is anything going on below that depth. Now, to show you the results for those stations, then you can see that all of those stations, this is the vertical motion we see. For Bangkok, yeah, this is a combination. I also put the horizontal. It shows you some effect from the earthquake, which was measurable also in Bangkok. You felt it. But we mostly want to look at those bottom graph and those three here. If you look at all those graphs, they all show that a downward trend. There is a seasonal variation, but that's something which we always see. That has nothing to do with the problem of land subsidence. We see it anywhere. But you see that all the trends of the station, one is RTSD, it's close to the city center, CSV, that's Chulalongkorn University, SPKN, that's the one at the mouth of the River Praya, at Samut Prakan, the naval dockyard station. And they all show subsidence up to 5 millimeter per year. This is lower than what you've seen from the SAR, but as I explained to you before, the SAR is relative. If the whole area is going down at 5 millimeter per year, the SAR cannot see. So that would be even 5 millimeter per year. For the deeper layers, also subsidence is going on. So with this, we independently verify with another techniques that there is subsidence,
right.
at least at the depth below where the buildings are built on. So in addition to the local subsidence you see in the previous results. So in the new project, actually it was very nice. We have a Thai postdoc, PhD candidate working on that. It's nice. We didn't select her because she's Thai, but she had the best background to do it. She's going to look more on the water and pumping data going on. And as you see on the right, there's quite some sediment layers. I put them in colors below Bangkok area, actually the Bangkok plain. And we got also data from the Department of Groundwater Resources, so she's looking at. And what you see here is, you see how the water level actually went down in the wells till the end of the 2000. And then I think this was a good move from the government, at least for this area, that there has been put restrictions more on groundwater pumping, at least in this Bangkok area. And then you see actually that the water level in the groundwater, like you would have in your home, is slowly going up again, you know. But that doesn't mean, of course, that you then neutralize the effect from pumping many years, as I told you. But we're going to put this extra in the new study. Mm-hmm. And we're also going to look now also how we can see how the land subsidence responds to periods with heavy or less pumping.
Right.
This is, of course, only the Bangkok area. It would be interesting to see the Samut Sakon data, you know, for a similar one, because there we see the high subsidence going on, while this area shows a little bit less. So that's a nice thing, and we're almost concluding. So what we can do with all this, and there's been many talks in 16 years, 9 years, you know, what we can do. We can actually make scenarios. A scenario is just what, or a simulation, or it doesn't mean it's it's going to be the ultimate truth, but it can tell you, based on scientific data, what might happen. And for that, we mix in a couple of results already I showed you about the absolute sea level rise, which is measured by the satellites. The land subsided rate, we measure it by the GPS or also with the STAR satellite. And then, yeah, a little bit of tectonic in there, but this one we can just forget. We will not even include in that. And then, of course, we know the digital elevation models, which is a digital representation of the land, also made from a satellite, actually from a mission. It tells you the height of all the points in Thailand where there's a mountain, you know.
Right.
So if we mix this in, and just as an example, we assume, and this is quite moderate, we assume a moderate relative sea level rise of 1 centimeter per year. So that means we assume 5 millimeter sea level rise, which we actually have right now.
Just a
and then just to be polite because it's not anywhere 3 centimeter. I put the 5 millimeter per year. This is the one we see from the GPS for the deeper layer, you know. So that's a signal we seen up to 3 centimeters. So
Right.
it could make it worse. So the combined effect, we just say 1 centimeter per year. Okay. Now we can just let this 1 centimeter per year go through the map. So green was land, but now if the 1 centimeter per year, the sea is coming up, we can simulate this.
Right.
So this is based on the data, 1 centimeter. We call it moderate. So we move on to the next one. Yep. Okay. So there's the video. Before you start the video, what we did here, and this is already something we did 10 years ago, we wanted to see the impact. We assume the 1 centimeter per year. So on the right, you will see the total effect of sea level rise and land subsidence going
Right.
up. The blue will go up. And then you will see what this will mean for the whole, not only the Bangkok area, yeah,
Right.
you see here. And we go up to the year 3000, you know, so because human life is only 100 years. But this is what would happen. And we only would assume 1 centimeter per year, you know. But you see what happens if you would do nothing, the sea would come there. Actually, the sea has been there. That's why
Right.
the plane is there, because 13,000 years ago, we had a phase where the sea level was 5 meters higher than it was today. That would be about halfway. And then the sea smoothed out, actually, the whole plane. And then it retreated to the ice age.
Right.
So we have a natural cycle. Sure, we have a natural cycle. But now we seem to have a cycle. Even if people want to say it's natural,
Right.
that's okay. But we have to do something about it, you know, if not. So you would see what would eventually happen.
Right.
So any landowners in this area of Bangkok in the year 3000, they would be having fish farms, I think.
Fish farms.
But this is, of course, the land itself. The buildings, you could always put the foundations higher or go up, you know. So, but it's mostly the land or the sand outside, you know.
Right.
This is the real one, which is going to happen. So if we would put it on I think half a meter, which is what you also see in other simulations, then in 2050, yeah, there would be problems.
Right.
Okay,
Wow.
so
this is the year 3000.
Yeah.
Yeah, but you could stop it on 2050, and then you see already that quite some points in Bangkok already below sea level.
Right.
So the blue dot is everywhere where the land is going to be below the sea.
Right.
Of course, if you, like in Holland we do, if you build a dike and you don't allow the water to
Oh, wow.
to overrun the land, then it will still be land, you know. Holland have many areas which are 1 meter, 2 meters below sea level, but we protect them.
Right.
But if nothing would happen, yeah, then it would be slowly. It's a slow process, but slowly, eventually, you went up.
Surely,
the sea, taking
slowly
back the
but
land.
surely.
Yeah, it's a slow process. As some people think the whole area the whole city of Bangkok will
Right.
one day, like Atlantis, quickly collapse in the sea. No, that's not going to happen.
Okay.
And for the other cities, but it's a slow process, but it's surely occurring. So then
Wow.
then actually we come to the conclusions. I think we talk about. So as I mentioned, the sea level rise for sure we know now it's 5 millimeter per year, but it might increase, as you saw by the global climate change. You know, the warming
Right.
up of the Earth. So this factor might become even bigger in the. So as I mentioned to you before, what is important then is what the land is doing with respect to that sea. And we've seen you a couple examples that we measure from GPS as the deep below 20 meter the buildings are on those 20 meter deep concrete pillar. We see also 5 millimeter per year. The SAR, she's also that, but they also have sometimes buildings which are only built on 1-2 meter
Right.
fundaments. They show up to 3 centimeter per year, you know, in the past. Then the tide gauge data also show this rates up to 50 millimeter per year. That's a combined effect from the tide gauge measuring the sea going down, actually, while it's measuring the sea. So all this, I think, we see there is no way we can deny something is going on, you know. Then, okay, I don't want to factor in the tectonic subsidence. That's not a big issue for Bangkok, but
Wow.
it's a small factor if you want to go for the details. But I think the groundwater pumping and sea level rise combined effect is increasing flood lake in this area. So, and then to the conclusion, if you want to know, is my conclusion. It says that if no appropriate measures are taken, the greater Bangkok region, so not only the city of Bangkok, faces progressive coastal land loss, and increased and even permanent flooding during the next decades. So mostly the ground soil level, the actual soil, of course, is affected, and buildings also, but less. So what you get is at one point the water, your building is there, and the ground floor outside is going more and more down, and at some point it will become flooded or even permanently flooded because it's below the sea level. And then to answer the question, actually, is Bangkok going to sink in the next couple of years? No, Bangkok has already been sinking for more than 50 years.
Right.
It's already going on. I mean, it actually mostly due to urbanization and development. So it's a slow process, but it's there.
It's been ongoing.
Yes, and in the beginning it's not noticed, and the people at the sea, they don't really understand what's happening. But then we start to get more data also from the satellites, and we start to realize, yeah, we see it's clearly an issue. And now it's even speeding up due to the the climate change, you know, which is going on.
อาจารย์อานนท์ครับ you would like to share with us, help อาจารย์วิม
Well,
in this matter?
I think we can stop now if there are any questions from the audience about on the technical part, because what I'm going to do next is we toward adaptation and on human and social issues like Renaud already mentioned at the beginning.
Right.
But if there are any pressing technical question at the moment from the floor.
Okay, we'll wait for that. So อาจารย์วิม
Yeah, no, it's fine. I think in the end, I think there was the last slide, which I just want to say that we, the science community, we provide the data. We, of course, not involved in how it should be handled, but at least I think we provide good verifiable data for a local area like Bangkok. And then, of course, the social impact, the government has to take the appropriate measures.
Wow.
So we can go for
Q&A.
My slide.
Okay.
Q&A on the technical part, if there are any.
If there is any. Actually, we do have a very interesting individual who is the country director of Greenpeace Thailand waiting to come with us. So let's go with that first. Okay, I'd like to welcome through the meeting, online meeting, Mr. Thara Bukamsi, country director of Greenpeace Thailand, to share with us some of your data as well as add on or comment on what Dr. Anon and Assistant Professor Simmons has said. That's not Kuntara. That's Kuntara. Okay.
สวัสดีครับ Thank you very much for inviting me to join the international seminar. I just want to make additional point in relation to to speaker. Greenpeace as global organization. Especially we work together with office in East Asia, including Hong Kong, Beijing, and South Korea and Taiwan, to come up with the report. Actually, the report is a synthesized report building on the study, a previous study related to rising sea level. So we look at 7 cities in Asia, which are economic center and located on or close to the coast, to the coastal area, and then use data that are already available to analyze how the economic, the impact of economic, especially in terms of GDP, could potentially be impacted by extreme coastal flooding in 2030. This report actually part of the campaign, a global campaign lead up to Glasgow conference in November. So we look at from the perspective of worst case scenario using RCP 8.5 scenario, which is business as usual. So if we continue releasing greenhouse gas as usual, and what's going to happen in terms of sea level rise. So we actually use the population number and GDP, which are among of the index of economic development. So to calculate and accurately estimate the potential effect of sea level rise, to actually help make decision to protect local property, infrastructure, well-being of the population. And actually, because I am not able to share the screen, but if we look at if we look at the whole 7 cities in Asia, so total the analysis that we have come up with actually the cost of economic damage actually in total 724 billion US, more than 15 million people together with the land of 1,829 square kilometers across 7 cities in Southeast Asia, including Bangkok, Hong Kong, Taipei, Seoul, Tokyo, Jakarta, Manila, and Bangkok. And I think for Bangkok, we see, I think according to information that available, we see the number here. If we look at extreme sea level rise and coastal flooding in Bangkok in 2030, it will put around 12.2 billion of GDP in US dollar, and around 10 million people will be at risk. The impact of GDP account for 96% of Bangkok total GDP. So in summary, if we look at the worst case scenario where we continue business as usual, we cannot reduce greenhouse gas emission. This going to be a possible impact that's going to come with the rising sea level and also coastal flooding for Bangkok and also other coastal cities in Asia. I think that's pretty much about it, and then I'll try to send the link to the report if you are interested. Thank you.
Thank you very much, Mr. Tharabukamsi, Country Director of Greenpeace Thailand. Thank you so much for sharing with us your data. All right, so back to Professor Wim and Dr. Anon.
Okay.
All right, we do have a number of questions. All right, they're kind of scattered everywhere, coming from all of our media sources. So pretty much, maybe if you would like to touch base on the political and social impacts and political decisions on this matter first before we go into the questions?
This is the subject of my next presentation.
Oh.
Let's focus on the physical and technical.
Okay, let's go with physical.
Yeah,
all right.
Physical and technical.
All right, okay.
Yeah, because, I think.
Sure, no problem. Okay, we do have a question from our good friend from Brazil. Mm-hmm. He was asking, just maybe a quick one, Professor Simmons. South America, how bad would they be hit by the rising sea levels?
Okay.
You have any info on that?
Well, if you look at just at the global estimates, I think there was one of the slides. The global is also somewhere around 3-4 millimeter per year. So if they have a coastal area, of course it depends if you're on the sediment. So I didn't study the region myself, but any coastal region is facing this problem, and it might be increased if there is, due to urbanization, there is subsidence.
Right.
Of course, the cities built on a rocky soil, they only suffer the absolute sea level. So that's an important factor, But I didn't study South America in detail, but I think anywhere in the world, too, even in the Netherlands, too, Europe, we have to deal with this.
Right. Now, once the global temperature, the average global temperature hits 2 degrees Celsius compared to the pre-industrial revolution era, how bad is that gonna worsen the situation?
As you see, it's not a linear effect, So if the temperature goes up more, then you will see that the increase, it's now 5, and in 10 years you would say it's 1 millimeter per year more in 20 years, and suddenly it can become 2 millimeter, or 3 millimeters. So it's going up and more,
Right.
And then because it's so it's feeding itself, and then it's, of course, the effect is going to become stronger. This was a very moderate scenario we showed, So the temperature, of course, is linked. The temperature means more ice is melting, and the sea is warming up more, So the effect is even become bigger, from
right.
the sea level rise.
Let me give some clear picture. If average temperature increased by 2 degrees, okay, of course we will see higher rise in sea level. it may be in the order of around 1 to 2 meters. I think around that. We are not talking about 10 meters.
Right.
We are not talking about 20, 30 meters. But we are talking about maybe 1 or 2 meters from today,
right.
which is for Bangkok is already very going to be very difficult.
Yes, like Ajahn Wim mentioned that your house and my house will be fish farms, right? Then maybe, right? All right, we have a question from one of our editors from the DXC, the Disaster Communication Development Center. จะเป็นคำถามจากทีมงานเราใช่ไหมผู้ช่วยบก.ใช่ไหมครับ
Okay. Right.
เปิดไมค์ได้เลยครับเชิญเลยครับ
คนไหนอ่ะ
ค่ะเปิดแล้วค่ะ
โอเคถามภาษาไทยก็ได้ครับเดี๋ยวเต้แปลให้ครับ yes
ค่ะอาจารย์อานนท์คะจะถามว่าการทำอุโมงค์หรือกำแพงกั้นคลื่นหรือการควบคุมการสูบน้ำบาดาลเนี่ยจะช่วยให้ปัญหาน้ำท่วมกรุงเทพได้หรือไม่ในอนาคตอะค่ะ
อะไรดีกัน
เรื่องน้ำท่วมกรุงเทพมันเป็นอีกประเด็นหนึ่งนะเพราะว่าในวันนี้เราก็มีปัญหาเรื่องน้ำท่วมอยู่แล้วนะอันนี้มันยังอาจจะยังไม่ได้เกี่ยวโดยตรงอาจจะกับเรื่องของประเด็นในวันนี้แต่แนวคิดของการสร้างอุโมงค์ก็คือว่าในเวลาที่มันมีน้ำมันมีมาอย่างรวดเร็วก็คือระบายออกไปให้ได้นะครับนี่คือถ้าเปื่อมันใหญ่พอนะครับมันก็สามารถที่จะกันได้แต่เราไม่รู้เหมือนกันว่าการออกแบบที่เขาเคยใช้อยู่ในอดีตเนี่ยถ้าว่าการเปลี่ยนแปลงมันเกิดขึ้นในอนาคตเนี่ยปริมาณฝนก็ตามปริมาณน้ำก็ตามที่มันจะมีในอนาคตเนี่ยอุโมงค์ที่ออกแบบไว้มันรองรับได้หรือเปล่าการทำอะไรโดยใช้ hard structure เนี่ยนะครับข้อจำกัดคือว่าถ้าว่าทำไปแล้วเนี่ยมันไปเติมอีกมันยากนะครับเพราะฉะนั้นการออกแบบเนี่ยมันต้องทำไว้เผื่อแต่ในขณะเดียวกันในทางตรงกันข้ามเวลาคุณออกแบบแล้วเผื่ออะไรไว้เยอะนะต้นทุนมันก็จะต้องสูงนะครับนี่คือข้อจำกัดของการใช้ hard structure ครับซึ่งการที่จะมองในเรื่องนี้มันต้องมองให้รอบด้านว่าในที่สุดแล้วเนี่ยมันเป็นทางออกที่ดีที่สุดและเป็นธรรมกับทุกคนหรือเปล่าครับ
ดีแล้วยั่งยืนไหมอาจารย์คือคำนี้ที่ต้องการไหม
ยั่งยืนนี่มันพูดยากนะเพราะว่าในสภาพในปัจจุบันที่อนาคตมันก็ยังมีความไม่แน่นอนสูงเนี่ยนะครับการอย่าบอกอ่ะการทำอะไรที่มันเป็นถาวรลงไปแล้วเนี่ยถ้าว่าใหญ่เกินไปมันก็สิ้นเปลืองโดยใช่เหตุครับเล็กเกินไปมาแก้ไขมาเติมทีหลังเนี่ยจะแพงมากเลยเพราะนั้นการจะออกแบบอะไรเกี่ยวกับเรื่องที่เป็น hard structure เนี่ยต้องรอบคอบต้องมีข้อมูลรอบด้านจริงๆครับ
I see right the next question is from Mr. Kim Irvin all right I think this question would pretty much lead to your next presentation regarding political and social adaptation all right so you have sea level rise land subsidence, potentially higher storm surges with more intense storm events, greater runoff from more frequent intense rainfall events entering waterways like the Chao Phraya, all converging to produce a compound effect. Now, how is this being addressed with respect to the planning and resiliency in Bangkok and the Bangkok metropolitan area? Or maybe you could lead to your presentation, and then eventually you'll be able to answer this question.
This is very difficult to answer.
It is, yes.
Because
once we decide to do something or not to do something, eventually it will affect somebody and benefit someone.
That's right.
Right. So where is that middle line, right?
Well, I think it's a process that need to be taking care of those. Yeah. Why don't I start my? Yeah. Can I have my slide on adaptation?
PowerPoint ของอาจารย์อานนท์ขึ้นนะครับ PowerPoint อาจารย์อานนท์นะครับ
On adaptation.
Right.
Because we have heard that we are quite certain that the future will be worse than today. Of course, today is worse than the past. ไม่ใช่อันนี้ครับ
ไม่ใช่นี่อาจารย์
ไม่ใช่ครับอันนี้ introduction ผมมี2 presentation
มี2 presentation
มีอีกอันหนึ่งครับ
สักครู่นะฮะอาจารย์ All right, so due to the technical difficulties, I do apologize. Before we go to that, Ajahn, maybe let's learn from the Netherlands, all right, where pretty much Ajahn Wim is based. I mean, when you decide to, do this big dike, this big dam, were there like pros and cons that you were thinking about, and were there supports or protests during that process?
I think a main driver was, of course, when I think in the 60s there was a big flooding, and because of storm and wind combination, so the water actually broke the existing dikes, and areas flooded, and people lost their lives. I think this was a big wake-up call. I think also and also for the government, I think did not want to a similar event occur again. And then they started to think, we call it the Delta Works. They start to make a plan to protect the whole coastline of the Netherlands, because the Netherlands by nature is already located close or below sea level. Some of the land was actually won by pumping a sea empty, so many of the land below sea level there. And then they started, but I think it was a long project, but they had to make the decision to build it, but they did so. Right. Even today, we still have the fruits from that. So, I see. But yeah, of course, you need to. It costs money, but you want to protect the coast or the people living there in a way that they can live there. Then you have to at some point do something. But it's always a difficult question: how fast, or sometimes things have to get worse before real measures are taken. Right. It might be more expensive because you wait longer also. So.
Right. So it pretty much has to sometimes hit the fan first before people start to work.
I think that happens many places. Exactly. That's not something which is just for Thailand. We have seen that through history, or sometimes we only learn from the events. Of course, from this kind of events, we can learn from other countries as well. To do.
So, Ajahn Anon, back to you. As I mentioned from the start, that you are an advisor to a number of government agencies as well as governments before. So, the sinking of Bangkok, or the inundation of Bangkok, is inevitable. How would you suggest we adapt to the rising sea level?
Okay. So let me first. I can use this, right? Okay. We have heard quite a lot on the rising of relative sea level, but then what are going to be the impacts? Flooding is not just one. When we talk about the impact of sea level rise, I can separate it into primary and secondary effects. Primary effect, of course, water. We will have more water on land continuously all the time, or certain time of the year, of the month, of the day, and that's we have already seen in many places. Phra Padang, for example, in December, January. During the full moon and the new moon days, we have flood all over roads and streets. That's one of the issues. And a direct issue is the salt intrusion. Salt intrusion, salt can contaminate surface water and groundwater, affect agriculture, of course, plants, aquaculture, and many other things. But the salt or seawater is not contained just a table salt, not just only sodium chloride. Seawater contains quite high amount of sulfate. Sulfate is, and of course, when sulfate react with waste like organic waste, it became hydrogen sulfide. So in area where seawater contaminate with fresh water, the area tend to be rotten. The hydrogen sulfide or rotten egg smell that you can see tend to be more easy to occur. So that means the environmental quality control and have to be more concerned about all these effects, not just only the sea salt, but also there's many secondary effects. Its effects are, for example, on the landscape, on heritage site, historic site, that we have to think what to do about it in the whole area. On environmental quality, corrosion, of course, more salt corrode metals more easily. and also biodiversity. Certain species may disappear, and we may see different kind of species occur in the area because of salinity, because of the chemistry of the water exchange. We can see the community and household behaviors change, including health effects and others. These are the quite direct, not direct, but it will be major concerns in many places. You can see the cost of living will be higher. Maybe tax will be more higher for people living in the Bangkok area to protect the area. We may see domestic productivities decrease or change. Agriculture, industry, and services. These are the impacts that we have to list and discuss. We cannot just look at the only one issue like flood and okay, we want to protect the area from physical flooding, but we have to think of other things as well. So when we talk about adaptation, there's many, this is just examples, their list can be go on and on, but there will be adaptation through structures, like protection, dikes, a lot of people talk about that, sluice gate, pumps, right. Yeah. We can protect it, of course, but doesn't matter how much the cost will be. We can do diversion of water, like just a previous question, we can divert it through sideway, we can divert it to vertical way through tunnels and others. So these are the different kind of construction and structure that we can do it. We can use the temporary storage area, or in Thai we call monkey chic or gambling. These are also the kind of structure that we need to construct. And also in terms of structure, we can think of something of new construction design. In Netherlands, we will start living on the floating house and many other things. These are the things that go on and on. So right. In terms of different kind of structure and construction. We can talk about the non-structural. Non-structural, this is one of the questions that's been asked. It has to be separated into collective or the adaptation scheme that people, the community or the whole society have to do together. Right. And that, of course, have to be led by organizations like government, local government. We can talk about the land use policy. Mm-hmm. We can talk about the construction codes that apply to the area. Adaptation and response network, working together, so sharing of responsibility. And also we can think of something like subsidy, financial subsidy to certain kind. These are we need to have policy, right. Clear policy and policy that majority of the people accept that as a way for adaptation. But of course, individual adaptation could be also been doing. We have to think of behavior change. Do we still have to commute every day like what we are today? Every morning we get on the car, drive to the office, right. Get back. These are the behavior that maybe in the future may not be appropriate for more frequent flooding city or the area. Right. We have to be more resilient. And of course, there's the adaptation could talk about withdrawal or retreats. We give up this area, move to some other places. So, for adaptation, it has to be multi-sectoral, multi-scale. It has to be inclusive and direct. Well, the way is that we have to listen to everybody. Okay, we cannot just talk to the representative of certain sectors, representative of certain communities. Mm-hmm. But we need, but today technology, big data technology can enable this to be done. But it has to have some kind like a platform and other way we can do it. We can talk about compensation because not everyone will receive the same benefit from adaptation. There will be someone who are at loss, and how we can compensate to those. These are the issues that have to be carefully discussed, and it takes time. There's no shortcut. Okay, definitely there's no shortcut. Cannot be some magician come and tell you do this and then all the problems will be solved. No way. Okay. I'm coming to the quite interesting that we are at the public broadcast system, PBS. Doesn't matter Thai PBS, ASEAN PBS, or whatever. I can see advantage of PBS to play a very important role in this. Why? Because PBS is not government, but we work very closely with government relevant government agencies. We have capability to broadcast. We have capability to do on-ground communication.
Connect people.
And many. We have a good, strong civic network already. Okay. These are the assets that PBS, Thai PBS, they already have. And the last one is very important because we have public funding. Okay, we don't receive money from the government or from any sponsor or
So
anything.
technically, we don't take sides.
So yeah, ensure neutrality. So we like the PBS, especially Thai PBS, to think about it. The future, obviously the next 1 or 2 years, we like to see how PBS can play a role in this and help bring people together, government agency, whoever, put together. But of course, like I said, this process takes time. It cannot be done in not even 1 or 2 years. But the more people, the longer time we can settle more about the issues to be moved forward in the future.
Right.
Thank you.
Right. So just in case the members of the audience don't know, Ajahn Anon is actually one of the main members of the Board of Governors for Thai PBS. Therefore, putting the right man right on the right job. Right. Okay. So before we wrap this up, maybe if Ajahn Wim and Ajahn Anon would close up with maybe a 1-minute quick wrap up of Sinking Bangkok, the Countdown online seminar, please.
Right. I think that I'm still optimistic. I'm still have hope that Bangkok and surrounding area will still be able to discuss together, come up with some conclusion but not near future.
Right.
But for the moderate term future. So don't give up. I would say that.
Right. Ajahn Wim.
Yeah, from my side, I think from the scientific part, we want to continue our research, get more detailed information, and we will publish that, make it available, both to the public, of course, but also the government agency can get that. And that might help them also towards getting this adaptation or taking decisions. So we continue our work. And I would just want to add also the sinking of Bangkok is not something which, just to clear it out, it's going to happen in 1 day or 2.
Right.
It's a very slow process, and you still have some time. Not all is lost at this point, but of course you cannot keep on waiting, and because the situation is not improving, at least not from the climate part, which Thailand itself cannot change anything about it,
Right.
Sea level rise is here for all of us to deal with.
Yes, as both Ajahn Anon and Ajahn Wim has mentioned, along with all our speakers, that this is not an individual problem, but also something that we need a consensus and a group decision in order to not to prevent, but also to provide this global calamity that's going on. And the Disaster Communication Development Center, DXC of Thai PBS, would be more than willing to be one of the key factors in helping creating the common understanding of what awaits in terms of the calamity. And we're very lucky enough to be able to announce today that Ajahn Wim has decided to be one of the members of our board of
advisory board.
Thank you for the invitation.
Right?
I look forward to.
อาจารย์วิมนี้ได้ตัดสินใจที่จะเป็นหนึ่งในคณะที่ปรึกษาของเราแล้วนะครับ being one of the advisors for DXC. So just to welcome you, I would like to ask the senior advisor, Ajahn Anon, to please deliver a little token of appreciation to Ajahn Wim, please. And if you would just please look what's inside and show the audience
jacket okay
นะครับตัดสินใจเป็นที่ปรึกษาเราแล้วแน่นอนครับเสื้อทีมต้องมา The other side please all right that's it ASEAN PBS
I will walk like this on Bangkok.
you do that in this weather you do that
okay
Thanks a lot.
Thank you so much. All right, so ladies and gentlemen, once again, on behalf of Thai PBS, Delft University Technology, and UNDP, I'd like to thank you all for attending our online seminar, Sinking Bangkok, the Countdown. I'd like to take this opportunity to once again thank you, Assistant Professor Wim J.F. Simmons from the University of Technology, Delft University of Technology, Netherlands, and also Dr. Anon Sadit Wong. Thank you so much, both of you. นะครับแล้วก็ถือโอกาสนี้ครับทุกคนที่อยู่ใน Zoom, everyone in Zoom, we will say bye to the audience together. Okay, until next time, thank you so much for tuning in. สวัสดีครับ Bye.